Hi there. Now in this question we're asked to find the magnitude of the resultant force exerted by the string on this pulley here. And it turns out to be 12.4 newtons to three significant figures. So as usual, what I'm going to do is take you through this very slowly, but you might want to fast forward, okay? Now when it comes to working out the force on a pulley, a smooth pulley that is, we should be familiar with the idea that if we mark on the tensions, which are going to look something like this, they're going to act in these two directions, and those tensions, because it's a smooth pulley, are going to be exactly the same. And we found out what that tension was, the exact value, in the previous part of the question. It was 2/3 G newtons. Now that resultant force exerted by the string on the pulley acts in the angle, along the angle bisector of this angle in here. So it's going to act in this direction. So if I mark on those two angles, let's say we call them theta, that's that one in there is going to be theta, and this one in here is going to be theta. Then all I need to do is figure out what angle theta is, and then I can resolve in the direction of this dotted line, and I'd know that that resultant force would be t cosine theta, because it contains the angle here, plus another t cosine theta, 2t cosine theta in other words. And by substituting our value for theta in, we should be able to arrive at that resultant force, 12.4 newtons. Okay, so we need to find out what angle theta is. So I need to work out this third angle in the triangle. And I can get alpha straight away just by taking the inverse tan of 4/3. So we've got that alpha equals the inverse tan of 4/3. And if you do that, it turns out, if you're in degrees mode, to be 53.130 and so on degrees. Now we know that this angle alpha and this angle up here should total 90 degrees, because coupled with that 90 will give us 180. So to get theta then, theta must be equal to 90, take away angle alpha, 53.130 and so on, and just divide all of that by 2, and that comes to 18.434 and so on degrees. So now that I've got angle theta, I should be able to get that resultant force exerted by the string on the pulley, because that resultant force then is going to be equal to the two components of those tensions in this direction. Remember, the tension then can be split into two components, one along the dotted line, and for this tension, one perpendicular to the dotted line. And for this tension here, there'll be one component in the direction of the dotted line and the other perpendicular to it. Those two perpendicular forces have no effect. We're only concerned with the component of each tension in this direction. And because it contains the angle theta, each one of them is going to be t cosine theta. So you've got a total then of 2t cosine theta, t cos theta plus another t cos theta. So all I need to do now is substitute the tension, 2/3 G, into here and take the cosine of 18.434 and so on degrees. And that will give me 12.4, as you can see here. Okay.